Okay, so this one, you're looking at especially the x values. And so like 4 is okay, but -2 and -2, I'd say this is not a function. So I would say no, this is not a function. If you graphed it, -2, 5 would be, I don't know, something up there. And -2, 6 would be right up there. Those 2 points are vertical from each other. And so that's definitely not a function. Is it this is a function? Look at the x values, 2, 4, 6. That looks good, right? I don't have any problem with that. That is yes, a function. This one, if you drew a vertical line anywhere, it never crosses more than once, I'd say yes, this is a function. Determined, so this is a little tougher. Now it's like, not as a function, but is it a direct variation, which is a special kind of function, right? So you want to see, like, the equation we need for this is y equals kx. Right, so for this one, you want to you could plug in each ordered pair into that equation, right? So if you did, this would be, I guess it'd be 7 equals k times 28, which means if you divide by 28, k equals 1/4. Same thing here, if you plug in 9 equals k times 36, divide by 36, you get k equals 1/4, same thing. If you say 12 equals k times 48, divided by 48, you get 1/4. So k is definitely 1/4. So you want to plug that, once you figure out k is 1/4 for all 3 points, you say the equation, the function rule is y equals 1/4 times x. So that's the function rule. Find the constant of variation and write. So this one, again, let's plug it in. So the constant, by the way, is 1/4, and the equation is y equals 1/4 x. Another way, by the way, I'm thinking about this is if you solve this equation for k, which means you divide by x, so what we did on every step over here, you get k equals y over x. That has to be constant. So if you do y divided by x, 15 divided by 1, 15. Looks like k is 15. 20 divided by 2 is 10. Uh-oh, those don't match. This is not. It's a function, but it's not direct variation. Here again, I'm going to use the formula. So when you see this, just plug in, right? So y equals kx, so it'd be 4 equals k times 12. Divide by 12, you get k equals 1/3. So the equation would be y equals 1/3 times x. I find x when y equals 9. So if y equals 9, that would be 9 equals 1/3 x. Multiply by 3, you get 27 equals x. I think that would be your answer. Graph each equation. So this one, the y-intercept looks to be 2. So you want to graph that. And the slope is -3/2. So I would go down 3 over 2 to the right. So I went down because the 3 is negative, so it's a down direction is negative. And then 2 to the right because it's a positive direction when you go horizontally. And just keep doing that. Down 3 over 2, make another point. Up 3 over 2 the other way. Pretty soon you can draw your line as best you can to go through those points. Ooh, this one, you might want to put it into slope-intercept form. I would subtract 3x first. So you get -2y equals -3x plus 4. Sorry, it's kind of doing some funny things there. Divide by -2, y equals +3/2 x. Divide by -2, that would be -2. So -2, +3/2, up 3 over 2 to the right, up 3 over 2, down 3 over 2 left, and you got your line. Find the slope, even gives you the slope formula there. So this would be, doesn't matter which point you choose, as long as you're consistent. 5 minus 2 over -2 minus -1, which is boom, boom, plus a positive there. So this would be 3 over -1, which is -3. So put it in standard form. So this one, different points, I'm guessing. Yeah, okay. First, let's figure out the slope. So it would be 3 minus -1 over 2 minus 3. So that would be boom, boom, plus a positive. That's 4 over -1 or -4. So the slope is -4. We don't want to put it in that form, so let's just use slope-intercept form. So choose one of the points, y equals mx with b. So y is 3. 3 equals -4 times x, which is 2, plus b. So 3 equals -8 plus b. Add 8 to both sides. You get 11 equals b. We're almost there. Y equals, I guess the slope is, this is the slope, right? The slope is -4 times x plus 11. So -4 is slope, not -4x. And I need the x term first for this form to be true. So I'm going to add 4x to both sides. I get 4x plus 1y equals 11. And that looks pretty good. That looks like standard form. So percent form of the line containing this. Okay, so this will be 3 minus 2 over 2 minus 0, which is a slope of 1/2. Y equals mx plus b. So I'm going to choose one of the points. I'm going to choose this one. So this would be y is 2 equals 1/2 times 0 plus b. Well, that's easy to solve. B equals 2. So my equation is y equals 1/2 is the slope. That's my slope. Times x plus 2 is your y-intercept. Find the equation line in that. So let's find the slope first. This is 3 minus -2 over 2 minus 5. Boom, boom. That's 5 over -3. So -5/3. So I'm going to go ahead and write my equation. I'm going to choose this point. So it's going to be y minus y1, which is 3, equals -5/3 times x minus 2. You got it. Find the equation of the lines whose point P that are parallel and perpendicular to L. So first let's find parallel. So parallel means it's going to have a slope of 1/2, and it's going to go through this point. And this is kind of easy in a way in that they happen to give us the y-intercept. So this first, the parallel line would be y equals 1/2 x plus 2. The perpendicular line would be y equals, you flip it and change the sign, so that'd be -2x plus 2. It still has the same y-intercept because it goes through that point. If it wasn't that point, you could have used, remember you can use this equation, right? You could have just said y minus 2 equals 1/2 x minus 0. That could be the equation. That's the equivalent of this equation, right? And then you could just plug in the slope of -2 and get the equivalent of that equation. So y minus 2 equals -2 times x minus 0. And of course, putting x minus 0 is not necessary. You could have just said x there. Okay, so this one, you're going to put some data in the Inspire. So let's just call this xc for x coordinate, 1, 3, 5, and 7. Call this yc for y coordinate, 20, 14, 4, and -1. Put your cursor out of that last cell, hit the home key, go to data statistics, choose your x coordinate, choose your y coordinate. Okay, so to me that looks negative for sure, as a negative slope. And Looks pretty strong, maybe. Let's see. So let's do some regression here. So analyze regression, linear regression. And you can see like the R squared value there is 0.98. That's pretty strong. One is the strongest there. So I'm actually pretty happy with that. So if you want the equation, y equals negative 3.65, decimal point there, x plus 23.85. And again, just describe it. It is negative and strong. That's what the correlation is. Describe each transformation. So the 2 is a vertical stretch. The 1 is going to go to the right 1. And the 3 is going to go up 3 inwards. Negative is going to reflect across the x-axis. The 4 is going to move it left. 4. Okay, so we're at the equation. So now we're kind of asked to use the equation, which is, so we've got y equals absolute value of x. If I want to go to the right 2, I would say minus 2. If I want to go up 3, I'm going to say plus 3 at the end. So this one, different way of asking it, y equals absolute value of x. The x value is 3, so h is 3, so x minus h plus k, so this would be minus 5 because k is negative there. Be sure to identify the vertex. So if you start with your 5 points you know and love, flip them down. So it's like an up, downward facing V. I don't know if you can see that. I'm kind of making them real light here. I have different colors in this one. So this is going to move. So this reflected it down. I just did that. It goes to left 3 and up 2. So every point goes to left 3, 1, 2, 3, up 2. That's my vertex, and negative 3, comma 2 is my vertex. Everything else goes left 3, up 2. Looks like this. Oops, something like that. So this is one where I would write out the ordered pairs, right? So 0, 0 is going to be multiply the y value by 0. 1/3 times 0 is 0. 1, 1 is going to be 1, comma 1/3. 2, 2 is going to be 2, comma 2/3, I guess. 3, 3 is going to be 3, comma 3 times 1/3 is 1. Negative 1, comma 1/3. Negative 2, comma 2/3. And negative 3, comma 1. Really, if you just plot this point, and this point, you probably have a good idea. So 0, 0, 3, 1, and negative 3, 1. So V shape like that. Oh, I don't know why that's not the final graph. So I've only done the 1/3. Now I have to subtract 1, so everything goes down 1. So this is the final graph. Sorry about that. This is not the final graph. That was the in-between graph. It was only after multiplying all the y values by 1/3. We're almost there. Okay, last couple. Just we've got to shade these things, graph them. So this goes to the left 3 and down 4. So one way of doing this is just start with that point, right? So left 3, down 1, 2, 3, 4. You could have graphed the parent graph and moved every point. This one's kind of straightforward though. It's going to be a solid line because of this sign. So it's solid, so I know this is a solid line. And I think the shade is going to be greater than, so I think it's going to be above. So I think I'm shading above this, kind of inside the V there. If you plug in a point like 0, 0, let's just plug that in. 0 is greater than or equal to absolute value of 0 plus 3 minus 4. So 3 minus 4 is -1. Is 0 bigger than -1? It is. That should be in the shaded area. It is. So I think I shaded correctly there. -3. So at -3, I'll make a horizontal line. Y is smaller than that. So I think I'm going to shade down. If I tested a point like 1, 1 here, so is 1 smaller than -3? That's not true. So 1 should not, that point should not be in the shaded area. It's not. And that's it.